Final version of Singleton we're going to take a look at here, the final implementation, is one that uses a Java AtomicReference. Now, we've done some discussions of AtomicReference in class. You've got a chance to play around with AtomicReference for assignment 2A. And this is going to show how to use AtomicReference, but be aware this version is deficient in a number of important ways, which we're going to take a look at when we run the program. So here's what we're going to do. We're going to make ourselves a static AtomicReference that is parameterized by the class that we're making a singleton. And we call it singleton, singleton AR, and it starts out with an initial value of null. As before, we have a field. It's non-static. We have a constructor. And this is an important constructor to keep an eye on because this constructor is actually going to get called multiple times. One for each thread that is going to be accessing the singleton through its instance method, as you'll see. The setter and getter methods are the same as before. Let's take a look at instance. There's a couple of different ways to do this. We could use compare and set. I'm using update and get just to be a little different. And what we're doing here is we're using a feature of the AtomicReference class called update and get. And what update and get does is it takes a look at the current value of that AtomicReference, which in this case, as you can see, it starts out null. And if the value is not null, in other words, if we've been initialized, we return the value atomically. Otherwise, if the value is null, then we go ahead and make ourselves a new instance of this singleton AR atomically. Now, as I said before, the trick here, the tricky thing here, and the reason why this is not as desirable, but I'm showing it because it's kind of interesting. The constructor will get called once for each thread that calls the instance method. However, only the very first constructor will actually be used as the value of this AtomicReference. So if you don't care whether your constructors are called multiple times, and maybe you don't, in this case, we don't really do much, this approach is perfectly fine. Chances are that it's not going to be that much faster than the other approaches, thereby warranting the use of multiple constructor calls, but just showing you what you can do and how it might work. Irrespective of what we do with update and get, we return the singleton's current value. When we call get on an AtomicReference, it returns the value, which in this case will not be null. It'll always be a constructed value. So that's the fourth and final implementation of singleton that we're going to look at here. What we're going to do now is we're going to run the program. So let's go ahead and run the program, and we'll see some interesting things when we run it. One of the things you'll see when we run it is that the enumeration implementation of singleton, the volatile implementation of singleton, and the holder implementation of singleton all only call their respective constructors a single time. As you can see here, singleton E creates the singleton once. Singleton H creates the singleton H once. Singleton V creates the singleton once. However, the one that uses AtomicReference creates it one for each thread. Remember, there's two threads that are going on here. So that's an argument in favor of not using singleton AR. And then if you look at the actual implementation, you'll see the very first time the values, the fields are accessed, the field is accessed, it's got a null value because it started out as null. And then after we get its null value, then we go ahead and update it to be its thread ID. You can see here that's what it's going to be after the update. And so for each of these different implementations, the very first time in, their field value is null. And then after that, it gets updated. And then, of course, later, when the next thread comes along, it'll find the older version of the thread, whichever one got set earlier, that'll be the name. And then after we update that, then it'll have its name. So this is just illustrating sort of the concurrent access dimensions of how different threads are calling set field and get field and updating things and getting back the values and so on and so forth. So key thing to remember here, there's many different ways to implement singletons. The one that uses enums is pretty cool because there's really no ceremony with double check locking optimization. And so that might be a good one to think about. But This will give you a better understanding of how you can take patterns that have been around for a long time, like the Singleton pattern, and then improve their implementations in various ways through the use of advanced Java synchronization mechanisms, especially as it reflects and deals with locks and atomic operations.